So in this class, we want to look at the derivatives of trig, logs, and exponentials. So looking at them in a summary way. Okay, so just going direct to the important points. So we start with trig. So we have if one f of x is equal to the function sine x, then the derivative is going to be cosine of x. So that if f of x is equal to sine, say, ax, the derivative is now going to be, you first differentiate the angle ax, you get a, and then multiply by the derivative of sine, which is cos, and then write the angle, which is. So we're applying chain rule now on the trig. Okay. So that the function, if it's changed to f of x, it becomes maybe sine of ax to some power n. Then chain rule now becomes more serious. You first bring down the power, write the whole sine ax to the power n minus 1, and then differentiate sine now. You get cos of ax, and then differentiate ax now. So you get a. So that a, I'm multiplying it with the n that is outside here. We are doing this, everything multiplied by a. So that we can write it as n a, and then the cos of ax multiplied by the sine ax to the power n minus 1. So it's extending the chain rule. We start with the normal sine. What if it has some function as an angle? What if it has some power and then there's some function as an angle? That's how we differentiate those pieces there. The second, we're talking of f of x being the function cos of x. Well, if you differentiate cos, you get negative sine. Okay, so that should be enough for cos. The other two pieces of sine there is the same. You just carry on if it was sine, if it was cos. Then 3, but we understand that tan of x, it was to be f of x is tan of x. But we understand that this can be written as well as sin x over cos x. So if you use the quotient rule, now that you know the derivative of sine and of cos, and you also know quotient rule, to get the derivative of tan is simply sec square root. Okay, and if you're given f of x, the function cot of x, you know this is the same thing as cos over sine. If we use the quotient rule, you say let u be cos x and let v be sin x. Then the derivative of cos is negative sine. Derivative of sine is cos. So when we put the derivative, we'll say u prime v minus v prime u over v squared. That would be u prime is negative sine multiplied by v, which is sine. And then minus v prime is cos multiplied by u, which is cos. And then divide by sine squared, which I'll write as sine multiplied by sine. But then that is negative sine squared minus cos squared. So if I factor out the minus, I'll have minus, and then the sine squared plus cos squared. And you know why I factored out? Because I'm getting one there. And then this is the sine squared. This is minus 1 over sine squared x. And what is negative 1 over sine squared x? Just minus cos x squared x. So that's for cot. So we have for tan, we have for cot. What about for sec? So if f of x is equal to sec x, well, we understand sec is 1 over cos, which if you want, you can write as cos of x to the power negative 1. So if we differentiate, we are dropping the power using changing, and then multiply by cos x, and then subtract the 1, we get negative 2. Then differentiate cos x, we get negative sin x. What are we getting? Negative times negative there, we get positive sine over cos. You now have to be squared. So it will be, and then this is sin x over cos x multiplied by 1 over cos x. So sine over cos, that's tan. And the 1 over cos, that's it. So that's the derivative of cosec.
So it means we have to swatila these to my formulas.
Yeah, so I'm driving you so that in case you're interested in how they are derived. But the key thing is just need to know that if f is sec, then its derivative is tan sec. That's all. But in case you forget, then you can quickly drive it. Like that. So that you can also see that, well, if f of x, the sixth one, if f of x is cosec x, well, you know this is just 1 over sin x, which you can write as sine x to the power -1. So if you differentiate it, you obviously get negative sine x to the power -2 multiplied by cos x. So we're getting minus cos x over sine squared, we can write as sine x, sine x. What are we getting from there? Cos over sine, that is minus cot, multiplied by 1 over sine, which is cosec. So you just need to know that, wow, sec is giving tan sec, cosec is giving cot cosec. So sec and tan will still be there in the answer, but you just have to multiply it by the other. If it's sec, you multiply by tan. If it's cosec, you multiply by cot. So that's for trig. Then now we go for logs, and then we'll go for exponentials. So just this page here helps you answer any exam question that comes on trigonometric differentiation. Just this page here, this summary of everything about trig differentiation is here. We have all the 6 being differentiated here. So you see when we do examples how it becomes very nice.
Sir, I'm kindly a bit behind on why are you multiplying by the cos x?
Where?
The sixth one, the sixth question you gave.
So we're using chain rule. We're using this. There's a power outside. So you first write it under the power, and then differentiate it outside. If you are given u to the power n to differentiate, you first bring down n, then u, n minus 1, then differentiate u.
Okay, sir, thank you.
So we got to the next. I now present logs. To differentiate logs of a very easy task. If you are given f of x as ln of any function u, okay, where u is a function of x. To differentiate this, you will have to differentiate the function u and then divide by the function u. Simple. 2, in case they give me f of x, whose base now is not e, say the base is a, and that is u. To differentiate this function, all I need is a derivative of u, and then I'll put down u multiplied by the ln of a. Meaning I will have to change the base from a to e. So any other base given, change it. You have the derivative. This is the easiest one. So I rush you to the examples. Find dy dx. 1, y is equal to ln sin x. So in this case, what is our u? Our u is sine. So I'll let u be sin x. and then differentiate it. Derivative of sine is cos x. Then I'll come back and say, oh, so what is dy dx? Oh, dy dx is just the derivative of u over u, which is what? Which is cos x over sin x. I'm done. If I know that this is cot, I can write it as cot. That is if I know. If I don't know, I'm done just beyond cos over sine. 2, they are given y is equal to y is equal to log 3 x squared plus 4x minus 7. So you say, okay, the base is not e now. Okay. So I'll have to do dy dx is equal to, I differentiate this guy, I'll get 2x plus 4 over, I copy the whole thing, x squared plus 4x minus 7, then multiply by ln 3. That's all.
On the other one, the first one, you don't put back the lien.
No, because the base was e initially. So if you look at the methods there, look at 1 and 2, how they're different. When it's lean, the lean doesn't appear in the answer. When it's not lean, the lean appears in the answer.
Okay, thank you.
Okay. Next. So this is enough for lean, we're done. For logs, we only have 2 methods. One is when the base is e, that is when you have lean. The other one is when the base is not e. And that's all. Then I want to talk about implicit now. Implicit differentiation. This is where you're given, say, y to some power plus maybe a y to some other power, maybe plus x some other power is equal to maybe the function, whatever, u. The concept here is if I'm unable to solve for y and they still want me to find dy dx, what then do I do? If I can't make y the subject, but they still want me to find the derivative of y with respect to x. So I'll come back here and say, okay, I'll differentiate yn as if it's just a normal function x to the power n. So I'll say n and then y, subtract the 1. But because I've differentiated y as if it's x, then I'll multiply it by dy dx. Plus, I'll do the same to the next one. Am y m minus 1 and then dy dx. And then I'll differentiate u minus I differentiate x. Notice as I'm differentiating x, I've taken the other side already because I know on the left I'm looking for all those that have dy dx. So now I'll factor out dy dx as I put these together, plus am, and then y m minus 1 is equal to u prime minus n x n minus 1. Well, then divide by ny n minus 1 plus am y m minus 1. Divide here by ny n minus 1 plus am y m minus 4. Because I know this will pass. And so this is my dy dx. If you haven't understood anything there, then that's okay. I give a direct example now where I can understand. Okay. Find dy dx. Find dy dx. 1, given a function sine y is equal to cos x. So if you try to solve for y here, you're going to have sine inverse of cos x, and then having differentiated sine inverse. So you get stuck there. So what do? Well, I just differentiate y wherever it is as if it's x. So I'll differentiate the whole sign here and say this is cos y. But because there's y inside, I multiply it by dy dx. And then differentiate cos x, I get negative sine x. Then divide by cos y and divide by cos y. So we have dy dx is equal to negative sine x over cos y. That's all. So I can still treat y as if it's x. But if I do that, I'll just have to remember to multiply by dy dx.
So,
You know?
I haven't understood like how you have solved the same question because I think I had just some challenge with network.
That's okay. You pick one where you understand now. You want to do the derivatives of exponentials. So if you are given a function y is equal to a to the power x, well, what we know is how to differentiate the logs and not the exponential. So we also know that, well, if x is in the power, you can apply ln and apply ln on the other side as you seek. And so this becomes ln y is equal to x multiplied by ln a. So we haven't differentiated here. We're just trying to bring it down to the normal function where x is not in the power now. We haven't had a function which we differentiated where the variable is a power. This is the only case that we are meeting, unfortunately. So we bring in logs so that we bring down that power. And then now we can differentiate. Or we have learned how to differentiate ln, except that this our ln has a y. So implicit now says, okay, differentiate y as if you have ln x. Differentiate as if you have ln x. Okay, how do you differentiate ln x? You would first differentiate x, you get 1, and then divide by x. So in this case, we would differentiate y, we get 1, and then divide by y. But because we differentiate y, we multiply by dy dx. That, and when you multiply by dy dx, then you again here you differentiate x, you get 1 multiplied by its coefficient, then a. Remember we are solving for dy dx. So have dy dx is equal to y times ln a, we get y ln a. But what is y? Well, y is ax. So this means we are multiplying ax by the ln of a. That is if what you have as a base is not e. Because what could happen if the base was e? If the base was e, if y was e to the power x, well, you know you're going to do all this. But when you get here, your answer is going to be dy dx is equal to ex multiplied by ln a, but a is e. But you guys know that ln e is 1. So this would just come out as e to the power x. So meaning when we have the base as e, we just differentiate, we just pick the ex if it's just ex. Where things will change a bit is if we have y is equal to, say, e to the power u, where u is a function of x. This one, as we are getting dy dx, we just have to remember that we first need to differentiate the power and then multiply by the whole function. This is the formula now for e. So that if it's not e, it's a, and then the function is u on top as its power. Its power now is a function as well. What do I do? Well, I just say okay, dy dx is simply the derivative of u, okay, multiplied by a to the power u, and then ln a. Another formula.
So anything multiplied by dy dx is dy dx. For example, there where you said 1 over y multiplied by dy dx, you said it's dy dx.
We didn't say. We cross multiplied. We multiplied throughout by this y. That's why it's a on the right. Remember, there was no y on the right, is it? What brought this y is because we had to multiply this side by y and this side by y. That's why the y has come here. For it to remain like that. Okay. So if you wanted an example, we are saying, okay, if y is equal to e to the power sin x, then the derivative y prime is going to be, you differentiate sine, you get cos x, and then multiply by e sin x. Yes. But if you had y is equal to 2 the power sin x, the derivative, this is the difference, the derivative was going to be, you differentiate sine, you get cos, and then you multiply by 2 sin x, and then also multiply by into, if the base is not big. Okay, so keep the methods today, look at them, and then you have the tutorial sheet. Every time you look at the method, check if there's any question you can solve in the tutorial sheet. If I should mention, today we have done tutorial sheet 10 from question 2 all the way up to question all the way up to question 10. From question 2 to question 10. The main task remaining for us is to do question 11 up to question 15, which are the applications of what we've done today. I haven't solved the direct question in the tutorial sheet because I want you to practice. So we run through, we've gone question 5, we've just done 1, you can try B or try C. Go to question 6, you have the derivatives of sine here, cot, cos, tan, cos, sec, tan. I've done all this. Differentiate each of the following: 10 to the power x minus 9 to the power x. We have some differentiating a to the power x. So where there's a, you put 10, where there's a, you put 9. You have the derivative. And then I'll differentiate e to the power x, that's not a problem. Differentiate 20 in x, that's not a problem. If you find this a fraction, that's quotient true. If it's a product, that's product true. Differentiate 7 to the power cos x, well, we're just from doing 2 to the power sin x. So what's the difference? So after question 10, I shouldn't expect any question from you. From those questions, from question 2 up to question 10. You enjoy the solving? We'll come to it again.
So I have a question before we cut the video.
Okay. You can ask.
Sir, when differentiating trig and functions, is there anything that you're supposed to follow? Let's say you have f of x is equal to x to the power 3
Mhm.
cos squared x. Then they tell you to differentiate that. Obviously, you're going to use product rule. Is there anything that you're supposed to follow to say your u can be x to the power 3 or your v can be, or you can just use them?
For product,
You
then
can
matter.
choose u. It doesn't matter if u is x to the power 3 and v is cos squared x, or the other way around.
For product, it doesn't matter. I can say V is x3 and the U is cos squared x. Where it matters is x3 over cos. Here it matters. Because the one that goes, the one that is up, you differentiate it and then multiply by that and then subtract the derivative of the one that comes from down. And then you square the one down. So this matters. Product doesn't matter.
Okay, sir.
All right, good night.